Hello, this is Arisui and I would like to welcome you to this part of video as it's the last part of the assignment. I'm going to concern with the first exercises where I worked with the high dimension dataset focused on prostate cancer classification. This dataset was including 79 samples and 500 predictor variables. This representing the gene expression level. This posed the classic example of curse of dimensionality, where the small sample size compared to the large number of predictors increases the risk of overfitting. This response variable indicated whether the sample was cancerous or not. For this, with the relatively imbalanced distribution between the two classes, for the classes are cancerous and non-cancerous, as I said before. The primary goal for this exercise was to identify the most relevant predictors of cancer classification and to develop and evaluate machine learning model including k-nearest neighbors and decision tree with the different CP while addressing challenge like overfitting and generalization. The third goal was to apply statistical and visualization tool to interpret model performance and the data structure effectively. Let's move to exploratory analysis part, where for this part, the data distribution, the response variable was balanced and near equal counts of cancer and non-cancerous cases. This is beneficial for training and biased classification model. For this part, the key predictor using Kruskal-Wallis test, I identified the nine most powerful predictors as shown here, like this X21, 78, 44, and all these 9 most powerful predictors. For this, among these 9, there are two predictors that show the separation, the most separation in box plots. For this, the one that show the separation, the best separation are these X21, 78, 44, and the X21, 19, 35 are showing this one, and this one are showing the most, like the best separation as shown here for these box plots. Let's go to the visualization. For this, I used the type H plots as shown here. This is the type H plot for the 9 best predictors, and this revealed the gene which are most distinct between cancerous and non-cancerous samples. Let's move to the classification tree. Here is the classification tree with CP 0.01. As we can see, the roots node was X20, 12, 90, 80, and this reference is strong predictive value as supported by Kruskal-Wallis tests. Will not take long as we can see here. Let's go to the model comparison and performance. For this part, we go to the ROC curve. Here is the ROC curve. Yes, these are the codes for ROC curve. For this ROC curve, we can see that I worked with the KNN varying for 1, 7, and 9, and the decision trees with TP 0 and 0.05 and 0.1. This shows that the KNN with the K of 1 performed the best and achieving the higher sensitivity and specificity. Overfitting and generalization, we can say that the lower K values capture the finest pattern but risked overfitting, while the higher K values moved prediction and reducing the performance. I would like to say more about this, but let's go to the conclusion where we don't have enough time. For this exercise taught me the variable lesson about working with high dimension data, and I learned to identify important predictor, balance model complexity, evaluate performance effectively, and so on. Thank you for watching.